Hey, what's going on, everybody? Homework assignment 33. Excuse me. We're getting into the fact that you will be able to express numbers in scientific notation and standard form. We'll talk about what all of that means. So, standard form are numbers that do not contain exponents. So the way that we normally see numbers are numbers in standard form. Scientific notation, it's a number that is expressed as a product of a factor and a power of 10. All right, and we'll be very careful about how we say these values. So if you take a look down low, in green, we have 3,500,000 written out for us. And that's the way we're normally used to seeing it. So we call that standard form of a number. Okay. Next to it, we have 3.5 times 10 to the sixth power. Now, 3.5 times 10 to the sixth power is the same thing as 3,500,000. If I take 3.5 and I multiply it by 10 to the sixth power, I will get 3,500,000. All right, and that is what we call the standard notation. Notice right now that this number has a positive exponent. So it has a raised to the power of 10 to the power of 6. Okay, 3.5 times 10 to the power of positive 6. And it's like that because it's a very large value. You know, we say a value that is greater than 1. All right, value that is 1 or greater, better yet. All right, it's going to use a positive exponent, greater than 1. Never mind 1 or greater. Greater than 1, we're going to use a positive exponent. Take a look at our number over here. We have 0.00004. That's the standard form. In scientific notation, this number can be seen as 4 times 10 to the negative fifth. Now notice our number is smaller than 1, so it's between 0 and 1. So it's 0.00. There's no whole number right here except for 0. All right? So it's going to be a very, 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 very small number. So we're going to denote it with a negative exponent. Okay? So keep that in mind as we go forward. Two parts to a number in scientific notation that we'll talk about. Obviously, our power of 10 has a base of 10 and an exponent of 6. You know, that's the terminology we've gone through. You know, we can call this whole thing a power, specifically a power of 10. 3.5 is what we're going to call our coefficient. Okay, so our coefficient is whatever this factor is that's being multiplied by our power of 10. So let's get into trying to express some numbers in standard form. All right. So 2 times 10 to the third power. Here's what we're going to do whenever we're writing these numbers in standard form. So I'm going to write out my 2. And I'm going to identify where the decimal point is on the number 2. Well, right now I don't see a decimal point, but we should know that there is a decimal point just to the right of that 2. Okay. Now, I'm going to take a look at my power of 10, which is 3. Because my exponent to my power of 10 is 3, then I'm going to move my decimal point over 3 places to the right. 1, 2, 3, because this is supposed to be a very large number. So here's where my new decimal point is. Therefore, 2 times 10 to the third is going to be equal to 2,000. Okay, so I moved my decimal point over 1, 2, 3 places because I have an exponent of a positive 3 right there. Therefore, my number in standard form is 2,000. So 2 times 10 to the third power is equal to 2,000. Same thing below. I'm going to rewrite my coefficient, 6.8. Already have a decimal there. I see that my exponent is a 5. Therefore, I'm going to move over 1, 2, 3, 4, 5 times. 1, 2, 3, 4, 5. This is where my new decimal point is going to be. I'm going to fill in everything else with zeros. And I could write out what that number is. So we have 6, 8, 0, 0, 0, 0, include my commas. Therefore, 6.8 times 10 to the fifth is equal to 680,000, okay? Positive exponent means that my number is going to be large, okay? I'm going to have a large value, meaning a value that is greater than 1. Now I have negative exponents. Let's take a look at what's going to happen here. So same deal. I'm going to rewrite my value here. So 3.2 0.25. But now, because I have a negative exponent, I'm going to, I didn't do too much. All I did was rewrite my value. Sorry about that. Because I have a negative exponent, excuse me, I am going to move my decimal point four times still, but instead of going to the right, I'm going to move it to the left. Negative exponent tells me that, 1, 2, 3, 4, that I'm going to have a very, very, very small number, okay? Include my zeros, 2, 3, and rewrite my number. So I have 0.0000325, and that's what this value is going to be equal to, 0.000325. All right. Negative exponent, again, means a value that is smaller than 1. So somewhere between 0 and 1. All right. If you have a negative exponent and notice that you have a very large number, then something is wrong. Let's take a look at this other one. So I'm going to write out my value, 1.3. I see that I have a negative 3. Therefore, I'm going to move 3 places. 1, 2, 3. There's my new decimal. Fill in zeros everywhere that I have empty spaces. And therefore, my value is going to be equal to 0.0013. All right, and that's equal to that value right down there. All right. So far, so good. We moved from scientific notation to standard form. So let's see if we can go from standard form now to scientific notation. So let's see if we could write our numbers in scientific notation. All right. So we're going to follow a very, very similar idea. So first, because we're going the opposite way, I'm going to start by identifying my decimal point. All right, the exponent always tells us about the decimal point. So notice I have a very large number, 4 million, very large number. Okay, it's a number that is much greater than 1. Therefore, I'm going to move 1, 2, 3, 4, 5, 6 until my decimal is to the right of that first non-zero digit. I'm going to say that again. I'm going to move my decimal point over until it is to the right of that first non-zero digit. Okay? So now I'm going to rewrite my value. So I know it's going to be 4 times 10. How many places did I move my decimal? 1, 2, 3, 4, 5, 6. Therefore, it's 4 times 10 to the 6th power. Same thing down below. I have 900. So 900 has a decimal point that's all the way at the end. Therefore, I'm going to move it until it is to the right of that first non-zero digit. Therefore, it'll move only, let me put a little arrow. It'll move only 2 places. So 1, 2. Therefore, my number in scientific notation will be 9 times 10 to the 2nd power. All right. Let's keep it going. Now, when we have negative exponents, notice that these values are very small. They're less than 1. So if my values are less than 1, what does that tell us? It tells us that my exponent is going to be negative. Okay. So let's go ahead and let's write this out. So let's find out where it's going to be. So I have my decimal point here already. I'm going to move it until it, once again, it is to the right of my first non-zero digit. So 1, 2, 7 is my first non-zero digit. That's where my new decimal point is going to go. So I can write out 7.2. How many places did I move my decimal point? 2 times. And this was a very small value. So it was a value that was less than 1. Therefore, I'm going to have a negative exponent. 7.2 times 10 to the negative 2nd power. All right. Last one. I want my decimal point to go right here. So I'm going to move my decimal 1, 2, 3, 4, 5 places. And this was a very, very small number. So we will have 6.4 times 10 to the negative 1, 2, 3, 4, 5, negative 5th power, okay? Negative 5th power. So the decimal point the decimal point tells us what our exponent is going to be, or vice versa. Our exponent tells us how many times I am moving my decimal point, okay? We'll continue practice on this. Take a look at those practice problems, and I will see you all soon.